In Creo Parametric, you can drive your models from a PTC Mathcad worksheet. Let's take a look at how to do that. Here I have a power transmission assembly. The input is on the right-hand side of the lower shaft, and it's going to be transmitted through the red shaft to the upper shaft, and then we'll have the output. And in this particular model, we have some 3D annotations that's giving us information about the inputs. Here we have the power, here we have the shaft speed, here we have the drive gear radius and the driven gear radius. And then over here, we have information about the outputs where we're calculating the torque, the shaft speed, and the wall thickness. And we're going to use the our worksheet to calculate some of these different values like the torque and the output speed and also the thickness. So before I jump into PTC Mathcad to show you my worksheet, I want to point out a few other things about here. Let me go to my parameters dialog box. We have a number of different parameters in here that define both our inputs and our outputs. So here's our shaft power, and we have it in kilowatts. And I want to point out the units that you choose need to be consistent with Mathcad, and also there are only certain kinds of units that you can use. And also some of our other inputs that we have in here, the input speed we're going to send over, and also the driven radius and the driving radius. Let's close out of here, and I'm going to hop over to PTC Mathcad to show you the worksheet. Here is the worksheet that's going to drive that particular assembly model, and this is actually taken from the Machine Design and Analysis Handbook. We've got some information in here. We have a diagram, a picture that's been placed in here that is showing the same setup as our model. We have the input shaft, we have our speed for the input shaft, and then the transmission from the driving gear to the driven gear. And this is sort of the layout of our system. We've got our bearings that are supporting the two different shafts. I'm going to scroll down in here. We have a number of different given parameters in here. And let me scroll down. After we have our given parameters, then we have our calculation procedure. So we're going to calculate the output speed and torque. So here's the output speed. This is one of the values that I'm going to pass back to Creo Parametric. Here's the output torque. And then it goes through a more involved calculation procedure to calculate the different forces in the model. And then from the forces, it's able to calculate the shear acting on the input shaft and then the bending moment. And then, let me scroll down over here. From the bending moment, it's going to calculate the equivalent torque and then use that to calculate the inner diameter. And that's what we're going to use to drive geometry in Creo Parametric. Before I go back to Creo Parametric, I'm going to set up my Mathcad worksheet in order to define my inputs and outputs, what's going to come from Creo Parametric and what's going to be sent back out. To do that, I'll go to the Input-Output tab, and I'm going to go to Show as List. And this dialog box shows that right now I have no inputs or outputs defined for going to or from Creo Parametric. Let me scroll down to my input values, and I know that I'm going to have the driven radius and the driven radius, so let's specify those. And to do that, you're going to specify one of the boxes and then click on Assign Inputs, and it's going to be added in here. Let's select this one over here and Assign Inputs. And it's right now using the name of the variable as the alias, but you could change that if you want to. And be aware the inputs are going to be your different expressions that are definitions. So our drive is defined as this value, our driven is defined as this other value. Another one of our inputs is going to be the power. Let's select it and then choose Assign Input. And the last one that I'm going to use is the shaft speed. And here we have it in Hertz. And my original spreadsheet had these in RPMs and had the shaft power in horsepower. But again, there are certain restrictions on which units that you can use. So I had to make some updates in here in order to make sure that I was using units that were compatible between both Creo Parametric and Mathcad Prime in order for running this analysis. So those are going to be my 4 inputs. Let me scroll down in here, and for the outputs, I'm going to calculate the output speed and send it back to Creo Parametric. So let me select the output, and then I'll choose Assign Output. And the difference between the inputs and the outputs is that this is going to be a definition, and this one is going to be an evaluation. And so here I've got my alias in there. That's good. Let me scroll down. I'm also going to calculate the output torque and send it back to Creo Parametric. So let me select that one and assign it as the output. And the very last one, let me scroll all the way down to the bottom of my calculations. The very last one, the diameter that is computed. Let's select that one and assign that as an output. So that's good in here. I can close this. Let me hit the Save button so that I have that information in my Mathcad Prime worksheet. Now I'm going to hop back over to Creo Parametric to set up my Prime analysis. All right, back in Creo Parametric, I'm going to go to the View Manager, and I'm going to apply one of the combination states in here because it puts in a nice cross-section and changes how things are oriented in here. It's sort of a nice way of setting this up. To do the Mathcad Prime analysis, you're going to go to the Analysis tab, and you have 2 different choices. There's Mathcad Analysis and Prime Analysis. If you're using a Mathcad analysis, these are for the old Mathcad 15.0, 14.0, and 13.0 worksheets if you want to connect them to it. But if you're using Mathcad Prime, you're going to use the Prime Analysis, and that's what I'm going to choose. I'll go to Prime Analysis, and here we have a dialog box over here. And now I'm going to load in the file. What it was doing in the background there is it was actually firing up PTC Mathcad in the background. I'm going to grab that particular worksheet. And again, it opens it up here. One thing I want to point out is that I have base units turned off. If you have base units turned on, that can cause some issues with passing your different dimensions and parameters from Creo Parametric to PTC Mathcad and back. So make sure that you have the evaluation of stuff in base units turned off. And we're going to leave this open. I'm going to minimize it. And now for my different ones in here, it automatically placed one of the values in here. What it did is I have auto mapping turned on. If I go to File and then Options, there is a setting in my configuration file. Let me scroll down to it. It is called, let me hit the Find button to find it. If you type in Mathcad and you search for your different configuration options, there's one called Mathcad Auto Mapping. I can have that set to yes. Let me change that and click Close and OK out of here. Now when I go to my Prime analysis, again, right now it's launching PTC Mathcad in the background. Let's choose to load a file, and I'm going to grab this file over here. It takes a look if you have auto mapping turned on for PTC Creo dimensions and parameters that have the same name and units as one of the values in the worksheet, and then it'll automatically map them to one another. So that did some of the work for me, but I need a few other Creo Parametric entities that I want to send over. Let's right click in here, and I'm going to select some different parameters. I'm going to explain later why you would probably want to use parameters. Let's grab a few of these different ones. And I'm just selecting them. I'm not holding down the Shift key. The other one that I want is the input speed. That's good. Let's click the OK button. And now let's say what they're going to be equivalent to on the PTC Mathcad side. So here we have the input speed. Let me right click on here and select a prime input. And here it notices that, hey, this is in hertz. One of the inputs I selected is in seconds to the -1, which is hertz. So that's good. Let's click the OK button. And then for the other one over here, let me right click and select the Mathcad Prime input. And for R drive, that's going to correspond to R drive, and R driven, same name input. Let's go to R driven and click the OK button. So that way I have these values being passed from Creo Parametric to PTC Mathcad. Now let's specify what we're going to get out of Mathcad and send back to Creo Parametric. I'm going to click the plus sign and then right click on the cell and choose Select Prime Output. And it sees all three of those things that were designated as outputs. I'm going to grab all three. I'm clicking on them and click the OK button. Now we're going to try to compute. And when we do that, it's actually taking those values from Creo, sending them to the worksheet, and recalculating and getting the values out. So for example, here it calculated the output speed, and here it calculated the torque, and then the diameter. And one thing is that my output speed right now is actually in RPM, so corresponding to what it would actually be in Creo Parametric, it should actually be 160 of that. And if I realize, hey, you know what, I need to make a change in here because right now my output speed isn't going to be correct, let's go back to PTC Mathcad and just make the correction so that I'm getting the correct output speed. There we go, that looks nice. Let's save that. Oops. Let's reload the file and then compute. And there we see now we have our output speed in the correct units. I performed the calculation. Let's click the Add Feature button. And now it's asking me for what I want to call this feature. For simplicity, I'm going to call it Prime because it is my Prime analysis. Now we have a feature in the model tree here called Prime. Let me click the Close button. And if I right click on the Prime feature and go to Information, Feature Information, it tells me that it is a Prime analysis feature. But the important thing is we have a number of parameters that have been sent back from Mathcad to Creo Parametric, and the name is going to be MCP, that's short for Mathcad Prime, then an underscore, and the name of the alias from Mathcad. We're going to use these to write some different relations in our model. Let me collapse this and go to my relations dialog box. And there we have some relations in here that is calculating the different parameters from model geometry. Now we're going to write some relations that are going to say what those different outputs from Mathcad should relate to on the Creo Parametric side. And we're going to assign them to different parameters. So I'm going to use the Insert Parameter button. And the first thing that I want to assign is the output speed. And the output speed is going to be equal to, and then I'm going to use the Insert button again. And instead of choosing one of the model parameters, I'm going to use the look-in drop-down list and change this to a feature to select the Mathcad Prime feature. And here are the different outputs. And that out speed is supposed to be equal to this R out value. I can choose Insert Selected. And now it's using this notation. It's got that MCP underscore route and then colon FID. That's short for feature ID number, and then 7967. So if I go to my model tree and add in a column for the feature ID, let me move this up over here and then click the OK button. Here we can see that 7967, yep, that is the feature ID of this Mathcad Prime analysis feature. Let's do that for the other different parameters. Let me hit the parameters icon, and we want to assign to the torque out parameter in here. Oops, I forgot to select it. Insert Selected, and we're going to say that that is going to be equal to, and then Insert Selected, and then again I'm going to change the drop down list to feature, and then use the pick icon to select the Mathcad Prime feature, and that's going to be equal to the T out, the torque out parameter. Let's Insert Selected, and one last one, we are going to use the Insert Parameter, and the last one is going to be the inner diameter, which is going to be used to calculate the wall thickness. Let's insert that, and that is going to be equal to insert parameter, change the look and drop down list to feature, select my prime feature, and then select the inner diameter, insert selected. And that's good. And if you don't like this FID underscore and that number because you're not sure what it corresponds to, you can change that to the name of the feature, which is why I recommend that you use a good name of a feature. And I'll just change two of them. I'll leave one of them the same. FID can either be the name of the feature or the feature ID number. That's good. Let's click the, I'm going to verify my relations first, just to make sure I didn't type anything incorrectly. That's good. Let's click the OK button. And I'm going to collapse all my columns in the model tree to give more space to the graphics area. And now I'm going to regenerate to make sure that we are going to have everything updated. Just going to regenerate a couple times. So right now, based on the input power of 250 kilowatts and the shaft speed of 40 hertz, we have a wall thickness of 8.755. Let's take a look at how we make different changes. I'll go to the parameters dialog box, and the first thing I want to change is the power. And for the input power, let's make this higher. Let's change this to a value of 300 and hit the enter key. And let's hit the OK button. And again, right now it's 8.755. Let's hit the regenerate button. And right now it's doing the regeneration. It's going through the model tree, creating the different features, and it's doing the Mathcad Prime analysis at the end. Because of where this is located in the model tree, I'm actually going to have to do a second regeneration so that it uses the values of the calculation to change the geometry in the model and the different information in the node. So now we see that the wall thickness changed to a value of 12.221. So the wall thickness increased because as you increase the power, you end up increasing the torque, and you end up increasing the bending moment, and then it recalculates based on the maximum stress of the shaft, and it ends up coming up with the new diameter so that it can survive that particular condition. Let's take a look at doing another change. Let's go back to the parameters, and I'm going to change the input speed. Let's change this to a value of 45 hertz, or 45 revolutions per second. Click the OK button. Again, I will do the regeneration. Again, it's sending the values to the Mathcad worksheet, performing the calculation, and then bringing them back. And after it does that regeneration, which I can tell I need by this little symbol down at the bottom of the screen, I'll do another regeneration. And earlier I had mentioned that you want to drive things from parameters when you can, because if you do that, if you plan everything correctly, you could have your Mathcad Prime analysis feature before your components, before any of your different features, and that way not have to do a double regeneration. But again, now we had changed the power. The power actually stayed at 300. We increased the speed, and our wall thickness was actually able to decrease in this situation. Let's take a look at one last change. Let's go to the parameters and change the input speed again. Let's reduce it one more time. Click the OK button, and we'll do our regenerations. And in this final case, we shall see. Actually, those are the same values as I used one other time. Let's do another change of the values. Let's try a combination of 250 and 40 for the speed. Click the OK button. And now again, we will do our double regeneration. And now we see that we're back to that 8.755 value. So again, the process for connecting your models to PTC Mathcad worksheets, one way is by using the Prime analysis feature. The process, once again, is we're going to have a PTC Mathcad worksheet, and we're going to have different definitions defined as inputs and other evaluation statements defined as outputs, and we're going to have different dimensions and parameters sent from Creo Parametric to Mathcad Prime. You'll perform a computation, get some different variables back, and then after you do that, you're going to use your different relations in order to assign those outputs from PTC Mathcad to different parameters and dimensions in your model so that it's driven by it. And be aware, depending on how you do this, you may need to perform 2 regenerations. But again, if you plan things properly and have your prime analysis feature at the beginning of the model or before the components or geometry, you can have everything powered by a single regeneration. I hope you enjoyed this video. For more information, please visit www.creowindshield.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button to be informed when new videos are uploaded. Thank you very much.